Optimization of products transportation and distribution network. Abstract. This research work focuses on the problem of transportation and distribution of products by a manufacturing company. The aim of the study is to determine the least cost of transportation and distribution of products by a firm. A popular brand in the food and beverage industry in Nigeria was selected for a case study. 2 of its plants in the southern part of the country were investigated. Distribution centers located at Umuahia, Awka, and Asaba are the destinations. Data of the supply from the 2 plants to the 3 centers, demand per period from each of the destinations and the cost of transportation from plant to each destination were obtained from the database of the company. The analysis of the data using Vogels' linear programming model reveals a total savings of 9,761,985 naira, #9,761,985.00. The research shows that Vogels' approximation method is effective in solving practical products transportation and distribution problems. Keywords: products transportation, distribution, network, optimization. Vogels' method. 1. Introduction. Transportation is the movement of people, animals, and goods from one location to another. Distribution is the process of making a product or service available for use or consumption by a consumer or business user, using direct means or using indirect means with intermediaries. A product according is anything that can be offered to a customer for attraction, acquisition, use, or consumption that might satisfy a want or need. There are various modes of transportation of products depending on size and urgency. Road transport is cheap, convenient, and one of the most flexible modes of transport. It is subject to heavy delays. It sets limit to and restrict the movement of certain heights, weights, and lengths of products. Rail transport is speedy, environmentally friendly, and not always subject to congestion or delays. However, it is inflexible. Air freight is without doubt the fastest to transport products across distances but is expensive and not eco-friendly. Air freight is carried by cargo airlines as well as scheduled passenger aircraft. Shipping by sea is relatively cheap, particularly if large volumes are sent. It is slow, and fairly inflexible with few ports, and further arrangements must be made to move the products inland. Sea freight vessels are made up of cargo ships, bulk carriers, tankers for liquids, roll-on or roll-off vessels. There are 2 types of shipping: liner vessels which operate on fixed routes with fixed schedules and tramp vessels which operate entirely according to the demand of the client. Couriers are business experts that operate fast, reliable and secured services. Couriers are expensive and only cost-effective over short distances. Factors that influence the distribution network design include customers' needs and the cost of meeting those needs. Goods and passengers movement in Nigeria are performed mainly by road, with the railway and inland waterways playing significant, but less important roles. International freight movement is principally by sea, while air transportation is mostly patronized by well-placed individuals. The supply chain is the chain links to each element of the manufacturing and supply process, from raw materials to end users. The supply chain consists of all parties that are directly or indirectly involved in fulfilling customer demands. These include the manufacturer, supplier, transporter, wholesaler, retailers, and customers. 1. The scope of supply chain can be defined in terms of the number of firms involved in the supply chain and the function involved. Dimension to consider include length of the supply chain and the numbers of suppliers and customers at each level. It is therefore clear that transportation and distribution are subset of supply chain. This research work focuses on these 2 elements. The transportation model has been used in movement of goods from plant to warehouse, resource allocation, assignment of work to machines, capital budgeting, and deployment of warship to locations. 2. Linear programming model is a mathematical formulation in which the objective function is linear. Murthy 3 defined linear programming model as a formulation for the allocation of scarce or limited resources to competing products or activities under such assumption as certainty, linearity, fixed technology, and constant profit per unit. The transportation model is a special class of linear transportation problem in which the objective is to transport a homogeneous commodity from various origins or factories to different destinations or markets at a minimum cost. There are few methods of solving transportation problems under linear programming. This includes simplex method, northwest corner method, least cost method and Vogels approximation method, VAM. According to Murthy, 3 Vogel approximation method has the potential to give the most optimal solution and will be used in this study. Other researches on product transportation are found in 4, 5, 6, 7, and 8. 2 Methodology. 2 plants of a production company in food and beverages located in Rivers State and Imo State, Nigeria were selected for the case study and call sources. Each center, Umuahia in Abia State, Awka in Anambra State and Asaba in Delta State, were chosen and call destinations. Quantities of products supplied from these 2 plants to the 3 demand centers were obtained. The costs of transportation from the source to the destinations were also obtained, and this data were inputs to Vogel's approximation methodology for computation and the determination of the optimum product allocation to these centers. 2.1 Model Formulation. Where is the quantity of products transported from supply point I to destination Jix? I equals 1,2 are Port Harcourt and Owerri plant, and J equals 1, 2.3 are Umuahia, Awka and Asaba demand center points, and are Port Harcourt and Owerri supply capacities respectively. 1a, 2a, and are the demand requirements at 1 Umuahia, Awka, and Asaba demand center points. 1b, 2b. 2.2 Input data. Tables 1, 2, 3, and 4 show the input data to solve the Vogels algorithm. 3 Vogels method and results. Step 1, creation of a dummy row to balance supply and demand as shown in Table 6. Step 2, the penalties for each row and column are written. This obtained by subtracting the least cost from the second least cost in each row and column. The column or row with the highest penalty will receive maximum allocation as shown in Table 7. Column 3 has the highest allocation with 578, and so the least cost cell, 3.3, is satisfied with maximum allocation of 520. This eliminates row 3 and new penalties are taken, resulting in the result of Table 8. Column 3 again has the highest penalty of 45. The least cost cell, 3,2, is satisfied with allocation of 234, thereby eliminating column 3. It reduces to the results in Table 9. New penalties are taken and allocation made as previously done. This eliminates row 2, yielding the tabulation in Table 10. The cell with the least cost, 1,1, is allocated maximum allocation, 694, reducing it to the form shown in Table 11. Table 11. Umuahia. Supply. 619. 242. Demand. 242. Total equals 242. Step 3, Table 12 below presents a summary of the allocations made indicated in brackets to the respective cost cells. Step 4, the table of basic solution is drawn. Table 13 shows the optimal cost of transporting the products to their destinations with the creation of a dummy supply center within these 3 centers of Port Harcourt, Umuahia, and Asaba. 4 Conclusions and recommendations. The cost of product transportation has been reduced from N$100,844,185, 100,844,000 naira, to N$91,082,200, 91,082,200 naira, with a saving of N$9,761,985, 9,761,985 naira, from 2 plants to 3 centers by using this method. Vogel's approximation method is hereby recommended for application in these industries. The burden of computation can be reduced by using computer algorithm and is recommended for future work.